All right, it's 10 o'clock here. Our timer's a bit off, but we'll go ahead and get started. Good morning. Thank you for joining us for this week's edition of the Long Coffee Break. My name is Chris Visconti. I'm a sales engineer on the hydronics, plumbing, and steam team here at Long. And I'm very excited this morning to be joined by Mark Dupuy with Vapor Power International. And Mark's going to talk to us about reasons why you should use vapor power for steam generation. Mark, take it away.
All right, thank you, Chris. So jump right in. So Vapor Power International, we are located in the Chicago area, and we make a variety of products, including steam generators. We have two different types of steam generators we'll talk some about today. We also make a line of thermal fluid heaters and electric boilers. We'll not be talking about the thermal fluid heaters and electric boilers. We'll focus our energy today on the steam generator products. So to begin, what is a steam generator? And reason we bring this up is different types of steam generators out in the marketplace. There are unfired steam generators or clean steam generators. That is not what we are talking about today. It's really one of our steam generators is just a boiler that produces steam quickly. So it's kind of a marketing phrase really to differentiate the vapor power product from a conventional natural circulation boiler. And so what we want to talk about today is some reasons why you would select a vapor power steam generator compared to a natural circulation boiler, whether it be a fire tube boiler or a water tube boiler. And you know, to start off, the vapor power steam generator typically has a little bit of a price premium associated with it compared to a natural circulation boiler. So the product offers then a payback to a customer to justify its selection and its premium price. So some of those reasons here are the fast startup capability, full modulation, safe operation, high pressure, compact size, and low weight. And we'll go into a little bit more detail on each of those reasons. And really, the more of these reasons that stack up on any given application, then the more the better justification there is to select the steam generator. So if it's just one reason, it's likely enough to justify it. But if you have four or five of these that all combine in your specific application, then the steam generator kind of becomes a slam dunk selection for you. So the fast startup, our designs can go from a cold start to full output in less than 5 minutes. And the reason we can do that is twofold. One is a low water volume in the steam generator, and the second is the forced circulation principle. So with all of our steam generators, we have a forced circulation design. So the water is being forced through the coils in the unit, and while you also have turbulent combustion gas. So for that reason, we're able to go from a cold start to full output in less than 5 minutes with no threat of thermal shock, compared to a fire tube boiler, where depending on the size, you typically have somewhere in the range of 30 minutes to 2 hours that are required for startup of that design. So if someone has, say, a 5-day-a-week operation or a 2-shift-a-day operation, and there's some downtime or steam isn't required for process, then with the steam generator, you can turn that steam generator off so it's not burning any fuel. And then when you need it again, within 5 minutes, it's up to full output. So what that saves you is fuel. It saves you some maintenance costs. It can save you labor costs by not having to come in 2 hours early on a Monday morning to start a unit, that kind of thing. So that's some of the payback that you achieve with the fast startup capability. Full modulation. So every one of our units is a fully modulating burner, and most of them have a 10-to-1 turn down. With the low water volume, we get a quick response to changing loads. So if the steam load profile is bouncing around quite a bit, then a steam generator will track that much tighter and much more efficiently than a natural circulation boiler. And we maintain then a high efficiency over the complete firing range. So the next slide kind of supplements this here and shows graphically kind of how we save a customer on fuel or overall energy costs with this. And it's something that you're not going to see printed on paper when you're looking at fuel consumption or efficiency statements by a manufacturer. It's something that really is going to apply to the application. So if you have a load that's changing with some kind of frequency, what we're showing here in the graph is that at 50% firing rate, you have to anticipate that ramp up to 100% with a natural circulation boiler. And so you're expending some fuel as you do that ramp up. Likewise, as you come down from 100% to say 80%, then the burner will quickly adjust to that 80% firing rate. So you can say, well, I've stopped adding fuel, but you've got a large mass of water, and that water has its stored energy in it. It will continue to steam off, and if the process doesn't have a need for that steam, then you're going to end up venting it out the building, and it becomes excess or wasted steam. And then we show it coming back up again. So with the steam generator, I always say that we square off those edges, and that leads to fuel savings. So again, the low water volume, forced circulation design, we change state very quickly. So as we go from a 50% rate to a 100% rate, the steam production follows that right alongside and squares off those edges. The easiest analogy that I commonly utilize when comparing the two technologies would be a large pot of water on your stove if you're going to make some pasta, and then a skillet with a small layer of water on your stove. And you turn two burners on at equal rate on your stove top. And then which of those is going to start boiling first? Well, the skillet with the small amount of water is going to start boiling first. And the large pot of pasta water is going to take a while to come up to get a rolling boil. So, and then when you turn that burner off, the skillet stops boiling very quickly. Whereas you turn the burner off on the pasta water, and you stopped adding energy to that pasta water, but you still continue to see steam rise off the top of your pot there. So that's kind of the analogy between the two. And what that can lead to is, depending on the amount of fluctuation, you get a 10% energy savings, or 10% more efficient with the steam generator. Safe operation. This is something where every boiler is made to be a safe boiler, but operator error can occur. And the small water content in a steam generator makes it an inherently safe design. You can't physically have a water side explosion or event with a steam generator. So in some jurisdictions that's recognized as far as operator requirements, but in general, you have an inherently safe design with the steam generator. The high pressure capabilities. So we can go up to 3,200 PSI in our design pressures. We can even do supercritical units. And so any kind of pressure, whether it's 300, 600, 900, even 3,200 PSI, we can accommodate those kinds of requests. The compact size and low weight. So this is a pretty significant advantage here, is that you have a 50% space savings. So on the left here in the photo, we have our 450 horsepower steam generator. On the right is a 250 horsepower fire tube boiler. You can see they take up the same amount of space. So you get essentially double the capacity in the same footprint. Another nice advantage to a steam generator is you can disassemble it and reassemble it on site without the need for any code welding. So if you have a limited access to a boiler room, a steam generator presents a very nice advantage. So again, you might pay a little bit more for the steam generator compared to the fire tube boiler, but if you save 5 times that on construction costs, because you don't have to knock out a wall or you don't have to build a new building, then you're justifying that expense. Next slide here, we've got a list of sample applications. And what this slide is really meant to show is that there's no 1, 2, or 3 applications that are a best fit for a steam generator. Any kind of steam application can be a good fit. It's just a matter of what the actual application details are and how many of those advantages make sense or apply to that application. So we'll spend a couple minutes here that we have remaining talking about combining steam generators in conjunction with natural circulation boilers, and kind of calling that a hybrid boiler room. So you're mixing technologies there, and what type of plant might you consider that in? So a retrofit application is a perfect example here. So if we've got a customer and they've added a new production line and it doubles their steam requirements for the facility, you can take out the old boilers in the boiler room and double that steam capacity by using steam generators and not have to make any kind of physical expansion to the boiler room itself. So you save all that construction cost, and it can really focus then on the cost of adding that production line. So that's the justification there. Sometimes this is just a retrofit of removing one natural circulation boiler with a larger steam generator, and then you can use them in tandem in the same boiler room. They do use the same chemical treatment. They do use the same deaeration and pumping design. So you can have a fire tube boiler and a steam generator on the same steam system, and they'll cooperate together. Summer load conditions. So this one applies pretty well for the area with a colder winter and a warmer summer. You can, on a campus type application, you can utilize an industrial water tube as kind of the wintertime boiler. And then in the summertime, when there's fewer students on site, and then also a lot warmer temperature, the steam load is reduced, and you can take that water tube boiler out of service, and then you've got, you know, an appropriately sized unit that is handling that load, so it's more efficient at that load. You save some fuel costs, you save maintenance costs. Short duration load swing. So here's a great example. If you have a production facility that has, say, a 10,000 pound per hour base load that's always there, then a fire tube is a great application or great solution for that application. Handles that very efficiently. And then if there's another 10,000 pounds per hour that is sometimes there and sometimes not, then that load can be handled by a steam generator. So you'd have your fire tube boiler as your base load, the steam generator takes up the peaks, and you kind of get the best of all worlds there. So you get a nice efficient fire tube boiler for the constant load, you get a nice efficient steam generator for the swing loads, combine that together, and you've got your best hybrid boiler room solution. Critical standby demand. So the classic example here would be a hospital application. And if you had a 1,000 horsepower load, a lot of what's commonly done is, say, 3 500 horsepower fire tube boilers and keeping one boiler on hot standby. And that works, but there's fuel costs associated with that. So another solution instead is to use the 2 500 horsepower fire tubes, but the third boiler be a steam generator. That steam generator can be kept cold until it's needed and then brought online, and in 5 minutes it's up to full steam. So there you get the fuel savings associated with that. You still have the backup unit available immediately. So there's an example of making your hybrid boiler room with a combination of technologies. And to wrap up here, we've got two types of vapor power steam generators. We have a modulatic design and a circulatic design. Our modulatic is a vertical configuration. It has size ranges from 18 horsepower to 220 horsepower, pressures to 3,200 PSI, 75-90 pounds per hour is redundant of the 220 horsepower rating there. And then we have our circulatic design that has a range of 75 horsepower to 600 boiler horsepower. Design pressures here up to 530 PSI. Very common to utilize this in a 150 or 250 PSI design application. And again, the 20,700 pounds per hour being redundant of 600 horsepower. And I'll turn it back over to Chris, and thank you very much for the opportunity today.
Thanks, Mark. There was a lot of great information. If anyone has any questions or needs any additional info on vapor power, please reach out to your Long sales engineer. Please join us next week when Brandon Pappas will be presenting on Carson Solutions, chilled beams, a perfect fit for an anticipated resurgence. Thanks for joining us, everyone, and have a great rest of your week.